Several factors can prevent a ground fault circuit interrupter, or GFCI, from tripping when tested with the Greenlee 5708 tester. Firstly, incorrect tester settings may be the cause. Ensure the trip current on the Greenlee 5708 tester is set to the appropriate value for the GFCI being tested. Typically, this value is 5 mA. Secondly, a faulty tester can give incorrect results. Verify that the tester is functioning correctly by testing it on a known good GFCI. If the tester fails on a GFCI that is known to be good, the tester itself may be faulty. Thirdly, GFCI overloading could be the problem. Exceeding the maximum amperage rating of the GFCI can prevent it from tripping. Check the load connected to the GFCI and ensure it does not exceed the specified limit. Each GFCI is designed to handle a specific amperage. Fourthly, improper wiring can interfere with the proper operation of the GFCI. Ensure that the GFCI is wired correctly in accordance with the manufacturer's instructions. Faulty wiring, such as reverse polarity or incorrect ground connections, can prevent the GFCI from tripping. Fifthly, the GFCI itself may be damaged. Physical damage or internal malfunctions can render a GFCI inoperable. Inspect the GFCI for any signs of damage and consider replacing it if any damage is found. If these potential causes do not solve the issue, several additional troubleshooting steps can be taken. 1. Use a different tester. Try testing the GFCI with a different tester, such as an analog or digital GFCI tester, to rule out potential issues with the Greenlee 5708. This can help determine if the problem lies with the tester or with the GFCI circuit itself. 2. Check the grounding. Verify that the grounding system is adequate and that there is a proper path to ground. A poor or missing ground can prevent the GFCI from functioning correctly. 3. Manually reset the GFCI. Press and hold the reset button on the GFCI for several seconds to see if it resets and functions normally. This can sometimes clear minor faults or issues. If all troubleshooting attempts fail, consider contacting a qualified electrician to inspect the GFCI, wiring, and electrical system for any underlying issues. A professional electrician has the tools and expertise to diagnose and repair complex electrical problems. Remember that electrical work can be dangerous, so if you are not comfortable working with electricity, it is always best to consult a qualified electrician. When testing GFCIs, it's important to understand how they function. A GFCI works by monitoring the current flowing into and out of a circuit. If there is an imbalance, indicating that current is leaking to ground, the GFCI will trip and cut off the power. This protects people from electric shock. The Greenlee 5708 tester simulates a ground fault to test the GFCI's ability to trip. The tester applies a small current to ground and measures the time it takes for the GFCI to trip. If the GFCI does not trip within the specified time, it may be faulty. However, it's important to note that some GFCIs are more sensitive than others, and some testers may not be compatible with all GFCIs. This is why it's important to try different testers and troubleshooting steps to accurately diagnose the problem. When checking the wiring, pay close attention to the connections at the GFCI receptacle. Make sure that the wires are securely connected and that there are no loose strands. Also, check for any signs of damage to the wiring, such as cuts, abrasions, or burns. If you find any damaged wiring, it should be replaced immediately. In addition to checking the wiring at the GFCI receptacle, it's also important to check the wiring at the circuit breaker panel. Make sure that the GFCI circuit breaker is properly installed and that the wiring is securely connected. Also, check for any signs of damage to the circuit breaker, such as cracks, burns, or loose connections. If you find any damaged components, they should be replaced immediately. When checking the grounding system, make sure that the grounding electrode is properly installed and that the grounding conductors are securely connected. Also, check for any signs of corrosion or damage to the grounding system. If you find any damaged components, they should be replaced immediately. A properly functioning grounding system is essential for electrical safety. It provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electric shock. If the grounding system is not properly installed or maintained, it can increase the risk of electric shock. In some cases, the problem may not be with the GFCI itself, but with the load that is connected to it. Certain types of equipment, such as motors and appliances with electronic components, can generate noise or harmonics that interfere with the GFCI's ability to trip. If you suspect that the load is causing the problem, try disconnecting it from the GFCI and see if the GFCI trips properly with the tester. If the GFCI trips properly with the load disconnected, then the problem is likely with the load. In this case, you may need to replace the load or install a filter to reduce the noise or harmonics. Another potential cause of GFCI tripping problems is voltage fluctuations. If the voltage in the electrical system is not stable, it can cause the GFCI to trip unnecessarily. Voltage fluctuations can be caused by a variety of factors, such as power outages, heavy loads, or problems with the utility grid. If you suspect that voltage fluctuations are causing the problem, you may need to install a voltage regulator to stabilize the voltage. It's also important to consider the environment in which the GFCI is installed. GFCIs are designed to operate in a certain temperature and humidity range. If the GFCI is installed in an environment that is too hot, too cold, or too humid, it may not function properly. In this case, you may need to relocate the GFCI to a more suitable environment or install a climate control system to regulate the temperature and humidity. When troubleshooting GFCI tripping problems, it's important to follow a systematic approach. Start by checking the most common causes, such as incorrect tester settings and faulty testers. Then, move on to more complex causes, such as improper wiring and grounding issues. By following a systematic approach, you can increase your chances of finding the problem and fixing it quickly and safely. If you are not comfortable working with electricity, it is always best to consult a qualified electrician. Electrical work can be dangerous, and it's important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on it, and use insulated tools. Also, wear safety glasses and gloves to protect your eyes and hands. Remember, GFCI outlets are designed to save lives by quickly cutting off power in the event of a ground fault. If you are experiencing problems with your GFCI outlets, it is important to troubleshoot the problem and fix it as soon as possible. If you are not comfortable doing the work yourself, call a qualified electrician to inspect and repair the system. In this specific scenario, since multiple GFCIs fed from similar panels are not tripping while others in the plant are working fine, it suggests a localized issue. It's less likely to be a plant-wide grounding problem and more likely to be related to the specific circuits or GFCIs in question. The fact that the GFCIs function using the test button but not with the Greenlee 5708 tester is a key observation. It indicates the GFCI itself is capable of tripping but is not responding to the simulated faults introduced by the tester. Double-check the tester settings to ensure they are appropriate for the GFCI type and that the tester itself is functioning correctly on the known good GFCI. Examine the wiring to each of the non-tripping GFCIs, paying close attention to neutral and ground connections. Incorrect wiring is a common cause of GFCI malfunction. Consider the possibility of nuisance tripping due to noise or harmonics on the circuit, especially if there are any new or modified loads connected to the circuit. Use an alternative tester as a cross-check to ensure that the problem is not specific to the Greenlee 5708 model. If the problem persists, replace the problematic GFCIs with new ones as a process of elimination. If new GFCIs also fail to trip with the tester, the issue likely lies elsewhere in the wiring or the tester itself. Ensure that the panel is properly grounded and that the grounding electrode conductor is intact. Although this is less likely to be the sole cause, a poor ground can contribute to GFCI malfunction.